Okay, hello everyone. So in this video I will provide a very simple and intuitive solution to the problem C of Codeforces contest 976. So I have already uploaded the video of problem A and problem B, and this one is for C. You can check out in my channel for the solution of problem A and B. Both are very beginner friendly and intuitive solutions. So yeah, let's jump to the problem statement first. Yeah. So problem statement seems to be pretty much straightforward. We are given three non-negative integers a, b and d. B, c and d. And we have to find a non-negative integer a in this given range such that it follow this condition. The condition is OR of a, b subtracted by AND of a, c should result in d. And if there is no such number possible, if there is no possible value of a, then simply we will give -1, right? And we have t number of test cases, and for each test cases we have to solve for particular b, c, d, right? So problem statements seem to be pretty much clear. Now, like for the beginner programmer, I just wanted to give this one intuition. Like whenever there is some kind of bit related operation, always first start your problem solving by spitting out the bits of every number. So you always have to think in terms of bit instead of simple decimal number system, because your question is now no more a simple decimal number system. If you will start thinking in the bit universe, then you can solve this problem very easily. Now we will just focus on particular bit. So I will write the problem. So basically we are provided with three numbers b, c and d, right? And we have to find for a particular condition a is such that the condition is a or with b subtracted by a and with c, and it should result in d, right? And we have also been given the range for a, which is this. We will look into this later, right? Now instead of just thinking of a, b, c, d in a simple decimal number system, we will think of them as just simple bits. Let's just consider what if the value of a, b, c, d will be a single bit, which is either 0 or 1. Let's just take this as example, right? So consider that at some point you want d to be 0. I mean small d to be 0. This is what your requirement is. So I will just write down some cases here. Now just think, what if your b is also 0 and c is also 0, then can you tell me what will be the correct value for a? Is it either 0 or 1? So you wanted to result d, which is 0, and b and c is already 0. So b and c is already 0. It means that if you end something with 0, this whole term will result in 0 itself, right? This whole term will become 0 itself. Now if you want the answer to be 0, you also want this term to be 0. So b is 0, we are given b is 0, so the possible value for a will be 0, of course, right? It cannot be 1. If it will become 1, then this term will become 1, but we want d to be 0, right? So here the possible answer value for a is 1. Similarly, if let's say c is I should write b is 1 and c is 1 also. And we I just wanted to clarify, we are writing these cases for particularly d equals to 0, right? So if b is 1 and c is also 1, if b is 1, then you see if you OR anything with 1, this complete term will definitely be 1, right? And you want 0 here, so this complete term should be 1 itself. I'm sorry for that. So this complete term should be 1 itself, right? So C is 1. To make this complete term 1, our A should also be 1, right? So here value of A will be 1, right? Okay. Okay, so I had missed one thing in this previous example. I wanted to make D 0, so D is 0 and this complete term is 0 and B is 0, and to make this term 0, I should make A's value as 0. So it was just a little mistake, right? Okay. Now similarly another case we can write it, which is, let's say if your B is 0 and C is 1. So if your B is 0, if this term is 0 and your C is 1, your C is 1. So if you make AND with 1, your value will result in this number itself, so A itself, right? And if you OR with a 0, it will result in A itself, right? Basically I just wanted to say, I can write this thing here. If you do A OR with 1, it will always result in A, and if you do A AND with so if you do A OR with 0, it will always result in A, and if you do A AND with 1, it will always result in A, right? So in this case, now this, if you put B equals to 0 here, if you put B equals to 0 and 1 or A or 1, this complete term will become A, and similarly this complete term will also become A. So A minus A is always 0 irrespective of value of A. So here we don't really worry about this case. So here A can be 1 or 2, both works. I should write both works. Similarly, now this one is a pretty much different case where B is 1 and C is 0. If your B is 1, then this complete term will always be 1, because if you are doing OR with a 1, then this complete term will definitely be 1 irrespective of value of A. And your C is 0, then this term will always be 0, because if you do AND with a 0, this term will always result in a 0. So this term become 1 and this becomes 0, so 1 minus 0 is always 1. So here there is no possible value of A, no possible value for A, right? So similarly, I want you guys to make this condition for D equals to 1. So I will just write it quickly, but I want you to pause the video and please write this condition by yourself. Now if your B is 0 here and C is 0 here, you want to find out what will be the actual value for A. So I know the values, so I will just quickly write them. Yeah, so if your B is 1 and C is also 1, then your A is basically 0, right? And if your B is 1 and C is 0, then your A can be 1, A can be 1 or 0, both works, right? And if your B is 1 B is 0 and C is 1, then in this case no possible value for A. So these were our sub cases. It is pretty much similar, not many cases. Now only what we have to do, we will iterate through bits 0 to 61. We will iterate through bit, and every time what we will do, we will make bit of B, basically it is just B doing AND with 1, and then for the next iteration we just have to write a right shift operator by 1, right? So you will get the current position, current bit of B, right? Similarly you can do for C, bit for C. So after this you have to make one right shift operator. So doing this at each iteration you will get the current bit for B and C. Now similarly you can do for D, similarly you can do for D, you can do like this, right? And then you will do one right shift for D. Now you have bit of B, bit of C, bit of D, and please remember we are doing this for iteration. I should make it to some indent. We are doing this operation for iteration 0 to 61, right? Because our range is provided as 2 raised to the power 0, 2 raised to the power 61, right? So yeah, so now what we have to do, we have value for bit B, C and D, and using this condition you can get what is the possible value for A, right? And we are given in the solution that if there are multiple solution, I think this should be given, right? If there are multiple solution we can print any of them, so there is not a problem, right? So every time what we will do, we have the bit value of B, bit value of C, bit value of D. We will input this in our this conditional logic. We will see that if the bit value of D is 0, then what is the bit value of B and C, and finally we will have bit value of A. And if somehow, if any iteration, if we will end up in this no possible value for A case, we will break our loop there and we will simply say that no, there is no possible value for A. And after passing all our bits to the operation, we will finally result in bit of A. And we have to combine this all bits to make a proper number of A, that we can do by A plus equals 2 raised to the power that bit. So basically we can just pick 1 and we can do the right shift operator, and what is the number of iteration we are doing, this will result in the power of 2. In the simple word I can write like this, 2 raised to the power id, the number of iteration we are working. And do we need to include that number bit in A or not? We can simply, first I can write this in small case. Now we can simply multiply this with bit of A. So we will get bit of A either 0 or 1. If bit of A will be 0, then this complete term will be 0, so there is no point of plussing it in A. And if the bit of A will be 1, then we will basically setting that particular ith bit in the A, right? Now for some clarity I can also show my code. So yeah, it's a pretty much simple code. This is simply my boilerplate. I just take the input of B, C and D. I can just take their input and I initialize the value of A with 0. And I have my flag. Flag is initially true. If somehow my flag become false, then I will just output that there is no possible value for A, right? Now I will iterate through all the bits. So for safe side I have done the iteration up till 64, but it is not really necessary. You can do up to 62 or 64. It not really matter, right? Now I have initialized the current bit of A as 0. Now as the condition there, I have written there, I will get the current bit value of B, C, D. So I retrieve the current bit value of B, C, D, right? Now I have my conditional logic there. So now I want you to write this conditional logic by yourself, right? This is pretty much simple. This is like by doing this conditional logic yourself, you will develop the intuition for the programming, right? So for simplicity, I have just written that let's say if you pick the bit of D is 1, if you pick the bit of D is 1, then what I have done, if bit of D is 1, so only possible case where we are going wrong is B is 0 and C is 1. For that case, I have put the value of false in my flag, and I have breaked my loop. Otherwise, I have populated the value of bit of A. And how is this? It is always the flip of bit of B. So I can see this observation, so that I don't have to write all these three conditions, right? This will save me so much time. You can see that every time when the bit value of B is 0, A is 1. When B is 1, A is 0. And when B is 1, A can be 1 or 0, it won't matter, right? Similarly, here you can see when B is 0, A is also 0. When B is 1, A is also 1. When B is 0, A can be 0 as well, because both works, right? So this kind of condition will save me writing the sub cases for these three conditions, right? These three conditions. I can only write sub case for this not possible case in both d equals to 1 and d equals to 0. So these type of things you have to see the patterns in the programming, so that this can save your time, right? And now similarly, when a bit of d is false, I have put out this condition. I have marked my flag as false, and I have break the loop. Otherwise, if this is not the case, I have just put the value of bit of A. And after all this logical condition, I have my bit of A. And for this particular iteration, I am making, this is basically 2 raised to the power. So I can write here 1 left shift I basically means 2 raised to the power I, right? But because we are doing in the bit manipulation, so it is good to do it this way. Then I can simply add it in my A. And finally, when my loops end, I need to check that my flag is false or not. If my flag is false, I can simply do it -1, simply written -1. Otherwise, I can give the actual value of A. So this is a pretty much simple solution for this problem. And I would suggest that you should have a basic understanding of bit manipulation, because every time when you come to the problem C, it will involve either dynamic programming, binary search with dynamic programming, or bit manipulation with binary search, bit manipulation with dynamic programming. Bit manipulation will be there a lot of time when you come to the problem C, right? So yeah, this was all. You can comment like if there is anything which you don't understand, or if anything in particular you wanted to understand for bit manipulation or mathematics or implementation based problem. I can make videos for that. Thank you.